Welcome, everyone. I'll state again that my name is Natan Silnitsky, and I'm a backend infrastructure developer at Wix.com. And this talk is about Greyhound, a high-level, event-driven, functional SDK for the Apache Kafka. And it is used by almost all of the 1,500 microservices on the Wix production environment. And I'm part of the data streams team at Wix, where we recently rewrote Greyhound from scratch, and we implemented it with functional design paradigm and the Zio library. So we decided to open source Greyhound from day one for the rewrite, and we offer a lot of cool features that I will share with you in a bit. First, I want to talk a little bit about how Kafka works so that we all be aligned. So Kafka is a message broker, and we have a producer of messages and a consumer messages that use Kafka broker as an intermediary for resiliency, etc. So when a message is produced, it's actually produced to a specific topic, and the topic is divided into partitions. And the message, while being produced, actually gets written to append-only log file. And it's very fast performance with this design. And you can keep messages basically indefinitely in the log file, although the default retention time is 1 week. And over on the consumer side, unlike traditional message queues, you don't actually, once processing a message, remove it from the queue. You just sequentially process a partition and commit a message once you're done handling it. And it's still kept in the partition for other consumers to consume, for instance, each one in its own pace. Okay, so Greyhound actually wraps the Kafka producer and Kafka consumer SDKs. And the idea here is to simplify the SDK APIs, remove boilerplate, add additional needed features for Wix services. That's where it started from. It's like an abstraction layer that makes it really easy to change stuff behind the scenes for all our microservices. So we can fix bugs, introduce features, and have them almost immediately in production for any service that will get redeployed. Now, for open source, we wanted to have as much access as possible. So we support multiple APIs. Of course, because the logic is written in Zio, we have a Zio API, but we also offer a Scala Future API and a Java API as well. Now, at Wix, we also have a Wix interop layer that basically has all the defaults that are required for how Wix services use Kafka, so that the services won't need to re-implement that again and again. And we offer, of course, Zio for Wix, but mostly Scala Future, as almost all of the JVM microservices are written in Scala with synchronous or asynchronous features. And we also, so that's why we also use the Scala Future API for Wix. And but we also have the open source flavors that I mentioned as well. So let's start with removing boilerplate and having better time with Kafka. Let's look at the Kafka SDK, Kafka consumer. So it requires to specify the key type and the value type of each record that's going to be consumed. And when you create a consumer, you need to specify broker locations and also the deserializer that will be used in order to actually be able to deserialize the key and the value. So that's already quite a lot of boilerplate. And here we chose to recursively have a recursive method to actually poll messages recursively from Kafka. Now we get the records, and we just iteratively go through the records and do some side effect. And once we finish processing it, we can commit the messages or the records. Now, Kafka does have auto commit feature, but you can, on very edge cases, maybe lose a message if you didn't finish processing it successfully. So it's best to actually explicitly commit the message once you're done handling it. Okay, so a lot of things are going on here. If we take a look at the Greyhound API, so this is the Zio flavor. You just specify a record handler and the dependencies that are needed for the handler logic are found in the environment type here. So we need the console to write to the console in the handler. And the error type is nothing, meaning that this handler code cannot fail, which is good. And the key and value type, similarly to how it is done in the Kafka SDK. So you just specify a lambda, and here it's, of course, written in a IO effect style, but there is also the future flavor, like I said. And then you just specify the handler as part of the consumer builder with topic and group, and that's it. You don't need to specify any Wix broker locations or other Greyhound consumer stuff like Kafka properties. All of that have good defaults in place for everyone. And you also don't need to specify commit, because Greyhound will, after processing this lambda, will commit the message for you. Okay, seems straightforward enough. Now, I want to switch sides and look at how we utilized functional design to help us better design of Greyhound. So we have the composable record handler. What do I mean by that? So the user in the service provides the user handler code, and we compose it along with other concerns that Greyhound has for record handling, and just compose one single record handler functionally. And that will be invoked by the Greyhound consumer itself. So here we can see a list of functions that the record handler has that actually allow for this composability. For instance, if we want to have some error handling logic, we can add it here to the record handler. So this is part of the core library that the APIs above use. And for instance, there's also the contramap functions. Contramap is similar to how you map the outputs to something else. With contramap, you map the inputs. So this is useful with the serializers function that, let's say we want to invoke the serializer. So we'll take the type of value and we'll actually change it and serialize it to an array of bytes, and then the other parts of the Greyhound consumer can actually work with this handler when it uses array of bytes, because that's the generic level and what is actually returned from the Kafka SDK. So this semantic really makes it easier to compose like Lego bricks all of the functionality of the record handler. And you'll see another powerful example of how functional composition helps with the Greyhound implementation a little bit later. So now we are drilling down into the Kafka consumer itself, the Greyhound consumer, sorry. So we have an event loop that will actually poll messages from Kafka, and it will then provide these messages to a message dispatcher, which will submit each message to the appropriate worker. And the worker will actually invoke the user handler code. Now, if you look at the event loop code itself, we can see that we are provided with the handler code, and we invoke the handle. And then we create the dispatcher, and the dispatcher will be able to submit messages through the dispatch. We'll be able to submit messages to our workers. And this will happen inside our poll function that will poll and actually invoke the workers. And we actually use a ZIO operator here called repeat while that makes certain that we are stack safe for our recursion, that it won't get to a situation of stack overflow. And we fork it to run on a different fiber. So a fiber is what ZIO uses for concurrency, and you can think about it as very lightweight threads. Now, notice that when we actually create the handler function here, we actually have an additional functional composition here. After the message is handled, we actually then invoke another functionality to when we manage the offsets. So here we will increment the offset that can be then committed to Kafka. So you can notice here that in the polling logic of the event loop, we commit the offsets after they are handled. And here, when we actually use the handler that we received from the user, we actually compose additional behavior to it. And it's done right here at the same place where we commit the offsets, we also increment them. In the old Greyhound implementation, this was not possible because we didn't use functional composition. So we actually needed to take the offsets and bring them all the way down to the worker class that actually performed message processing, and it incremented the offsets. So it's a really nice feature of functional design of local reasoning that you can really see what's going on with offsets management in exactly one place. Cool. So let's get back to features that Greyhound offers. A very important feature is, of course, parallel consumption. So if we take a look back at the Kafka SDK consumer, we see that we polled messages from the consumer, but we can't actually do that in a concurrent way because polling can only be operated from a single thread, meaning that if we wanted to do some multi-threading here, we needed to do that ourselves, submit to like some thread pool and process messages. And we'll need to do that according to the partition. It's quite complex logic. Or alternatively, we can set up multiple Kafka consumers to run at the same time for the same topic and group. But in this case, it will mean we use a lot more resources than we actually need because these Kafka consumers take up resources. So with the Greyhound consumers, we actually utilize the ZIO fibers I mentioned earlier, that are like lightweight threads. They are very cheap and also very cheap context switching for them. They take up a lot less memory. So we can actually run as many fibers as we have partitions assigned for this specific instance. So the Greyhound consumer polls the messages and will produce them through the dispatcher and to the worker for the appropriate ZIO queue. It will push the message, submit the message to a queue, and processing from this queue will be done sequentially on each queue on its own fiber, each partition on its own fiber. So it's a very efficient design and gives much better performance. We noticed a great deal of improvement in throughput at Wix services when we switched from the old multi-threaded environment of the old Greyhound to the new fiber-based Greyhound. So like I mentioned here, the message will be dispatched to the worker and handled on each fiber. Each worker will run the logic on its own fiber. Great. So that's very important for performance at Wix. What about error handling? We have a very big, I mentioned 1,500 microservices. It's a distributed system. A lot of things can go wrong with the logic of the services. It's really important to have fault tolerance. So Greyhound offers really easy retry policies to configure. You just specify here in this example, it's a non-blocking retry policy where the user specifies that it wants to retry after 1 second interval. And if that doesn't work, then after 10 minutes again. And it just provided to the Greyhound consumer builder, the retry configuration. So how does it work behind the scenes? We have our Greyhound consumer, and it has a built-in retry producer that will actually, in case of failure, produce the message to the retry topic. We have a retry topic per interval that the user has declared. And the message will be processed on the retry topic after the interval expires. And of course, if the message fails processing on the first retry, it will then be produced to the second retry topic. And this design of retry topics was inspired by Uber for Greyhound. And notice that there could be a lot of retry topics created automatically on your Kafka cluster because users will set up many intervals. So it's important to make sure that you don't have too many partitions on these retry topics to not get metadata overload for the Kafka cluster and start it behaving less optimally. So our default is just one partition per retry topic because it doesn't really have a high throughput usually. Now, we also have a blocking retry policy because, of course, when you produce the message to the retry topic, you then commit it on the original topic, and then you can process new messages on the original topic and maybe even successfully process them, meaning you'll get out of order processing. So if you need to make sure that you have ordered processing, for instance, when a topic you have updates events from source control and you want them processed one by one in order. So Greyhound offers a blocking retry policy that will just retry the same message again and again upon failure of processing. So here we see the very simple configuration. You just specify, for example, that you're going to have finite blocking of 1 second, and if that doesn't work, then after 1 minute to retry. And there are also other flavors. You have exponentially increasing intervals for blocking retries, or infinite blocking if you want to make sure that this message will eventually get consumed successfully. And all of this is powered by Zio scheduling that you can easily schedule all kinds of things with Zio. And of course, when you're blocking this message, it means that there could be a lag developed with the producer. The producer keeps producing messages and you're stuck in this partition on the same message. So a lag can build up. And for that, we actually created an automatic dashboard for each service where the developers can actually go check the message that is currently blocked and then decide if it's not a very interesting message, they can decide to unblock it. Or if they notice that there is a bug, they can go fix the bug, deploy the service. And because during the retry process, we don't commit the message until successful consuming, then message is not committed. Then after deployment, the partitions will get assigned again to any instance. And then hopefully, because the bug is fixed, the message will be processed successfully and the lag will start to go away. Great. So we talked about fault tolerance for the consumer side, but what if errors happen on the producer side? For instance, when for some reason a Kafka broker becomes unavailable, and that can happen even if you have a high availability cluster. So let's think about examples where we can afford having multiple retries for producing. Well, something like offline jobs where the user is not waiting for immediate result on the browser. So for instance, Wix payment service needs sometimes to renew subscriptions. So it gets the request from a job scheduler, and then it will produce the subscription renewal message to a Kafka broker. And then the consumer will process the message, try to renew, and will retry upon error, like the retry policies that I described earlier. But what if the producer failed to produce the message to Kafka broker because of some unavailability issue or network issue? So in this case, Greyhound has the resilient producer. It will first save the messages to disk and only then fetch them and try to send them over to Kafka. So if there is some potential downtime for Kafka broker, some network issue, then it will retry until the broker comes back online or the network issue is fixed. And of course, we are now living with Kubernetes deployments that are very popular. So the service is actually detached from the disk. So if the pod goes down, but messages are still accumulated on disk, then we have a dedicated Kubernetes daemon that will actually notice that the pod is down, and it will take on the responsibility of producing the messages to Kafka by itself. So we make sure that no message is ever lost. Cool. An additional feature, and it's the last one I want to go in depth on in this talk, is context propagation, which is very important for us at Wix. So consider a flow where the user visits site Wix, a customer visits a Wix site, and wants to sign up, be a member of that site. So we have a site member service that will get the request to sign up. Now, there is a lot of important information on the HTTP request, the user request context. What language is the user using? What geography? What's the user type? So we can have cookies in place to say, oh, this is a Wix user, a site owner, or this is a site visitor, and all kinds of other important information that will be sent as part of the HTTP request. But then we have a microservices environment where we want to propagate this user request context through Kafka events as well. So Greyhound will produce this context automatically to the Kafka as part of the record headers. And then downstream services like the context service can consume the message, and Greyhound consumer will automatically have the context available for context service to actually read and decide what they need to do with it. Maybe just write it to database as part of the new contact that is for this site owner. So here we see how easy it is to actually retrieve the context. Greyhound actually retrieves the context from the headers. So this is Greyhound code. And it actually will provide the context, inject the context into the handler logic, the user handler logic, through the Zio environment dependencies. So the user of Greyhound will then define this method, the record handling logic. So it knows that it has in its available the context of the record that Greyhound automatically populates, and it can also access the database. If this is the context service, it has access to the database. So this is, of course, a Zio flavor record handler. And we see here that we get a record handler with environment of database and record handler user context. So we can retrieve the context and write it to the database. So it's really simple and straightforward dependency injection, and it's quite powerful, I should think. And Greyhound also offers the ability to pause or resume consuming when your application maybe becomes unhealthy, maybe the database is offline, then you want to pause consuming and not get to a bottleneck and failures. And also Greyhound offers a lot of metrics that it reports that are very important for us. We have automatic dashboards in Grafana that report on lags, report on message sizes, on any important, also on handling time. A lot of important information that is really essential when you try to debug an event-driven distributed system. And we also want to introduce to open source Greyhound our batch consumer. We want to introduce the ability to have to employ transactions exactly once processing in the Kafka pipeline in Greyhound as well, and other consumer strategies that are more helpful for certain use cases. And all of this will be really much simpler to be implemented with Zio because of the powerful concurrency primitives that it offers. So like I mentioned, Greyhound is quite robust and really over the years is really battle tested for a ton of services at Wix. And there are a lot of use cases at Wix that use Greyhound in various ways. There's the classic pub/sub events, but also CDC. So Greyhound is used in order to populate Kafka with events emanating from database bin logs in order to have a more continuous event-driven flow. And also offline scheduled jobs, like I mentioned, because you can use the resiliency that Kafka offers for offline jobs. And also Greyhound is used for database replication between different Elasticsearch clusters in different data centers, for instance. And also action retries. Like I said, if you have a flow that requires retry, then Greyhound can help you a lot with that. And also materialized views. So if you want to actually take some CRUD database and make it, or event sourcing database, and make all kinds of different views, tables, or have the information optimized for queries in different kinds of databases from the original database source of truth, doing it with Greyhound and Kafka makes a lot of sense. So rewriting Greyhound in Zio resulted in code that has much less boilerplate. Also, the API is a bit cleaner. The code, the implementation is easier to follow and understand as long as you know the basic building blocks of Zio and IO and effect IOs. And it's really fun. It was really fun to implement, really fun to use Zio to do this like this. And we are able to introduce new features faster because of the powerful concurrency and error semantics that Zio offers. So this is the link to actually go and see and check out Greyhound in our public repo and at Wix organization. And like I said, it supports both Scala feature and functional style APIs. And we're currently at version 0.1.5. We're starting to see early adoption from the community, and we also got external contributions already. So we're very excited about that. And I would like to thank you very much. And also, I put all the slides here on SlideShare, so you can check out this link in SlideShare to get all the slides. And you can also follow me on Medium, where I put blog posts. I write blog posts on event-driven design and Kafka-related posts, Zio-related posts, and all general software engineering related articles. And you can also follow me on Twitter to get the latest on Greyhound and all the other services and libraries that we work on at the data streams team at Wix. And you can also check out my website at natansil.com, where you can find previous conferences, talks I gave in previous conferences. So thanks again.